Okay, geometry students, here we have the back half of your unit for review. And for learning target 7, this is intended to kind of be one of the easier ones. You don't have to do any proofs. But again, a lot of you struggled when we did the concept check on this one. So hopefully you have pieced together what you need to know for the isosceles triangle theorem, and then of course pretty much everything here you're needing some form of the triangle sum theorem to go along with it. So the first thing that I notice is, well, m and n are up here, but I don't have any information up there. I do notice that this right here is an isosceles triangle. And by the isosceles triangle theorem, I know the base angles have to be congruent. So if this is 68, then this would have to be 68. And the total there is 156. Now, that again doesn't directly help me with n and m, but it does give me some pieces because I know by the triangle sum theorem, 180 minus the 156 of these two has got to be equal to my third angle. And so 180 minus 156 is going to be equal to 24. Now I'm going one step a little bit beyond here, and I know that this angle and angle M up here are vertical angles, which means they have to be congruent. And so that gets me my first value, M is equal to 24. Now the second thing that I got going for me is, well, I know that by the triangle sum theorem, these three angles have to be adding up to 180 degrees. And I also, well, know that these two have to be congruent. And so n and n here are going to be the same. So if I take the 180, subtract out the 24, I know that these two things have to be 156 together, divide them by 2, and that gets me 68. So n is going to have to be 68. All right, looking at part B, you've been told that the base angles are congruent, and so you know by the converse that the two sides have to be congruent. And so that's just another way of setting up two equal parts. I got 2x plus 10, the stuff on the left, is equal to 8x plus 4, the stuff on the right. I go ahead and I subtract 2x from both sides, then I subtract 4 from both sides, and I get 6 equals 6x. Divide both sides by 6, and I get x equals 1. It does say find the length of AC, and so that means I'm going to plug 1 in for x. 8 times 1 is 8, plus the 4 is 12. All right, back to proofs. For learning target 8, you're either having to prove the isosceles triangle theorem or its converse. And so here, you've been given that the base angles are congruent. You need to prove, well, the converse, that AB is congruent to AC. So first things first, let's go ahead and create our auxiliary. So I say create AD so that it bisects angle BAC. That would be the top one here, and we call that an auxiliary. Well, now I'm looking for three parts that are congruent, so I can say the triangles are congruent. Well, I've got AD is congruent to AD by reflexive. And then, because I created this so it bisected the angle, I know that this angle, angle 1, is congruent to angle 2 by the definition of angle bisector. That gets me my second thing, but of course I've got the third thing, which was given to me originally. B and C are congruent. And so I got three things, and that's going to be by angle, angle, side. So by angle, angle, side, these two triangles are congruent. And then by CP, CTC, I know the corresponding parts are congruent, which will include AB and AC, which is what I wanted to prove in the first place. Okay, taking a look at learning target number 9. This is just a right triangle proof. So you know that in the end you're going to need to use HL, LL, HA, or LA. You know again that it's a right triangle proof, primarily because I told you right here in the instructions, but also mostly because we tell you right here that angle 1 and angle 2 are right angles. So if you have right angles, you have right triangles, and you need to say so. before you use a right triangle proof, you need to say that you have right triangles, and that's right up here. All right, let's see. So if that's the case, we say that we have right triangles. Don't say that they're congruent. That's kind of a common mistake. Students will they're used to saying things are congruent, so they accidentally put that here. But don't do that. Just say triangle and triangle are right triangles by the definition of right triangle. And sorry about that. It's the mix up here in the key, but angle 1 and angle 2. I actually meant to say angle 1 and angle 2 are up here. So these two are congruent because it says RT bisects angle SRU. So definition of angle bisector is giving me these two congruent. That's one piece. I've got RT is congruent to RT. That's by reflexive. Remember, with right triangle proofs, you only need to have two because this is already kind of like one of them. So I take a look. What are the things that I have? Well, is RT a leg or is it a hypotenuse? This is the hypotenuse. It's the one opposite the right angle. So this is a leg, and then angle 1 and 2 are angles. So this is leg angle. All right, your overlapping proof here. So you've been given a couple things. PR, so this little guy right here is congruent to IR. And then angle A is congruent to angle L. Well, if I want to prove that these two triangles are congruent, so if you can see triangle PRL, and then also triangle ARI, I want to prove that those two triangles are congruent. I've actually already got one part. I got the short leg of this triangle is congruent to the short leg of this triangle. And then I got the angles down here. So I got an angle, I got a leg. The thing that these two triangles share is angle R. Angle R is up here. They share that angle. And so by reflexive, I can say angle R is congruent to angle R. And that means, well, I got two I guess I got two congruent triangles, and that's by AAS. You can see angle, angle, side. And I can't stop there. We're going to go ahead and now say PL, another leg of that triangle on the right, is congruent to IL, its corresponding side to the triangle on the left. Those are congruent by CPCTC. All right, as promised, your process standards question looks very similar to what you had on those problem-solving days. And so you got Reese is making a map to hide his riches under a rock. You start at a fig tree, so I draw a little fig tree, and you find a barn that is 5 meters due east of the fig tree. So, all right, I actually measured that out with my ruler, and that's 5 centimeters. And then you're finding the rock, the large rock that's 50 degrees west of north of the barn. So here's north. West of north would be this direction. So there I measured 50 degrees west of north, which would leave me with a 40-degree angle here. And then it's 35 degrees east of north of the fig tree. So here's north. East of north would be this direction. So if that's 35 degrees, well, then I would have 55 degrees here. All right, it says sketch a map using 1 meter to 1 centimeter scale. So that's why I have 5 centimeters here. And explain whether or not it can be guaranteed that you can find the treasure using this map or these directions. Well, absolutely, because I have angle, side, angle. There is no other triangle that I can make, and so this intersection point is the only intersection point that I could get given these directions. So I say that we can be sure that the rock at this intersection point is where the riches are by the ASA postulate. And it also says go ahead and measure the length from the barn to the treasure. And you can just use your ruler, and you can find that that is 4.4 centimeters. So on this, it would be 4.4 meters. All right, that's it for your Chapter 4 review. You can spend the rest of the time in class reviewing and getting ready for your test on either Tuesday or Wednesday.